All right. Hey everyone, I'm David. I'm a solutions architect here at AWS, and most of my day is spent actually helping startups in New Zealand, build great products and take over the world. And as part of that, I have a specialty focus, which is on edge network security protections. And so tonight we're going to talk a little bit about how you can use AWS WAF, our web application firewall, to detect and mitigate bot attacks. Now, these are things, as we'll go into more detail, that are increasing in prevalence and something you're increasingly likely to experience if you're running a web platform. So it's important to understand, what are your options to help manage that. Now, I don't want this to be a death by PowerPoint presentation, so we'll have a few foundational slides, give you a bit of knowledge about the basics, and then we'll jump in and have a bit of a walkthrough about how you can set yourself up. All right. So we've got three different architectures here. The one on the left is a very simple elastic load balancer in front of an EC2 instance. The one in the middle has CloudFront as a CDN sitting in the front. And then on the right, again, very similar, but we have an S3 bucket hosting, say, your static content. Now, who here, a show of hands, has an architecture in their business that looks something like this? A few hands? Great. So the great thing about this is that each of these services, Elastic Load Balancers, CloudFront, has native integration with AWS WAF. So if you do want to implement any of this, you want to add some protections to your platform, you can do it without having to make any significant architectural changes. As you'll see, it's all point and click. And so what we're going to do today is walk you through how you can set that up to protect this kind of web application. All right, so what are some of the threats that you might encounter with an application architecture such as the one in the previous slide? So on the left here, we have an attacker, and it's unfortunately a little bit blurry, it's a little bit small, but there's two things to consider. The first is attackers now have a sophisticated toolbox of attack tools that they use to use against your website. And so they might be scraping data, they might be buying tickets to a concert, doing a variety of things from their computer. Equally now, and this is where it's becoming increasingly challenging, is that they're deploying these tools, their toolbox of tools, across thousands of compromised computers around the world. So not only are you having to consider the person sitting behind their computer at home, but it's the thousands of computers around. So those are the sort of threat actors that you'll typically encounter with that kind of architecture. And as part of that, there's two classes of attacks we need to consider. So the first is application attacks. So when people talk about web application firewalls, WAFs, including AWS WAF, the first thing they think about is the one at the top, which is web attacks. So that's your classic OWASP type 10s type stuff, your log4j vulnerability, you might remember that for a few years ago. Bread and butter web application firewall stuff. If you've got compliance standard like PCI compliance, then you probably have to worry about that for that. Where it gets a bit more interesting is bot attacks and credential abuse, and this is where someone is, writing a script to crawl your website to scrape down data, or, as I said, try and buy tickets to a local concert and scalp them later on. One thing to consider about credential abuse, so it's also quite common for attackers to go to the dark web, buy a list of username and passwords, and then basically use them to brute force your login pages on your website for people that use credentials across multiple platforms, which of course is quite common. So that's one class. The other class is denial of service attacks. So this is, in particular for volumetric and slow attacks, is where someone abuses the protocol or sends lots of TCP connections, those sort of lower layer vulnerabilities. Now, I will say that WAF itself isn't there to protect yourself against those types of vulnerabilities. That's something Shield, AWS Shield, or other DDoS mitigation techniques is there for. I'm not going to discuss that tonight. Where it is quite interesting from a WAF perspective is the HTTP flood. So it's quite common for a user to launch thousands of HTTP requests and flood your application. So those are the kind of things that you need to consider. And what we're going to talk about tonight is how you can mitigate those various classes of threats with AWS WAF. So first off, bots. So, there are good bots and there are bad bots. There's no such, necessarily, it is very much a continuum. So on the left, you've got good bots. So it's like the Google search crawler, for example. Like you probably want it. Your business wants it. It crawls your website. It helps with search engine optimization. It helps drive people to your business. Furthermore, it tends to be well behaved. So, you might not necessarily be worried about that. Search bots. Where it gets a bit, less clear is scrapers, those news aggregators, those aggregators that are crawling the prices on your website. The reason you might be a bit more ambivalent to them is that they're not so well behaved in terms of, they overload your website. And so that's when you start to think, okay, well, how do I detect those and how do I mitigate that so that it stops, affecting the other legitimate users to my website? And where it gets really interesting or really challenging, depending on how you look at it, is these stealthy bots. So people that try and deliberately evade detection, make it look like a real user, buy tickets to concerts, sign up for accounts and send spam, whatever it might be. So those are the ones that you really want to detect and mitigate. So what we're going to do today is sort of walk through how you can manage all of these with AWS WAF. So first off, I just want to talk about simple bots. So on the right there, we've got Selenium. So that's the screen. If you're familiar with Selenium, it's an automation test tool. Basically loads up a browser, points and clicks around the website. The great thing about this is that a very easy thing for this to sort of detect and manage it is that it's coming from a single computer. It typically identifies itself. So those are simple bots. To the point about sort of evading detection, this is where the advanced bots come in. So these, execute JavaScript, they generate valid browser fingerprints, they mimic human interaction. It's not like a brute force Selenium script pointing about your website, is that they actually go above and beyond to make it look like it's a human moving their cursor. And furthermore, they're distributed widely. And so it's not just one computer that you're seeing a lot of traffic come from, it's thousands all sending a very small amount. And so that becomes increasingly hard to detect and manage. All right, I said this wouldn't be death by PowerPoint, so this is what we're going to walk through today. So here we've got the architecture that we're going to demonstrate. So we've got a CloudFront distribution, and we're going to attach AWS WAF to that. We've got an elastic load balancer and an EC2 instance at the back. Now the EC2 instance is running what's called Juice Shop, which is an OWASP-based project that has a single page app with APIs and a back end, your classic React style application with a number of deliberate vulnerabilities in it. We're not actually going to test those vulnerabilities today, we're just going to use it to demonstrate some of the mitigation techniques, but needless to say, it's a pretty stock standard single page API based app. And to do that, we're going to do 3 classes of rules. So the first is IP-based rules. So we're going to detect what are the IPs that are sending these requests, and let's block them. So that's, again, helps with some of the volumetric type attacks. Then we're going to show how you can detect and block some of the more common or simple bots. And then finally, we're going to go against the harder to detect bots, those ones that are deliberately evading detection. At the end of this, what you'll have is basically good knowledge that you can take away, that if you do want to detect and manage this in your business, you can get it set up in hopefully the 20 or 30 minutes that we've got this evening. All right. So with that, we will jump into the AWS console. So I'm just going to go to CloudFront. Got a distribution I prepared earlier. Let me make it just a bit bigger. So I've got a CloudFront distribution. It's running at this endpoint. I'll just copy it and paste it to prove the point. that's not the one at all. Sorry, apologies. I said it was small, didn't I? Let's try that one. So this is the sample application we have. As you can see, it looks like a pretty standard shopping cart. It's got an API backend. It's generating this with a React front end. So pretty stock standard, something that many of you will encounter in your day job. I've gone ahead and already integrated this with AWS WAF. So you can see here, there's a native integration. What this means is that if you've already got a CloudFront distribution, you can get up and running with this very quickly. So I'm just going to open it up now. And I'm just going to bring up the rules. So I've got no rules associated. So everything that just, is allowed. There's nothing blocking any traffic. And what I'm going to do now is the first rule I'm going to add, remember I said we're going to work with IPs first, is a rate limit rule. So I'm building my own rule. I'm going to call it rate limit. I'm going to make it a rate-based rule. And I'm going to make the rate limit 100. And what this is saying is that in any 5-minute period, the maximum number of requests that can come through from a given IP is 100 requests. After that, it'll get blocked. So this makes it a very effective denial of service attack prevention because you can't have one IP trying to flood your back-end application. At a certain point, it gets blocked. So, you might be asking, well, why don't I just make that lower, less than 100? 100 is the limit that AWS has. One thing to be aware of is, in terms of networking, is that one IP might be serving the traffic for lots of your end customers, not just one. So you do need to be, it is very much how do you manage that workload or interrupting legitimate users. And you can see here I've got the action, which is blocked. Can everyone see that? No, make it as big as I can. Yep. So I'm going to go add rule, and I'm just going to save it. So I've got my first rule here, rate limit. What I'm just going to do is prove that this still works. Yep. Now what I'm going to do is I'm going to show what happens when it's no longer, when you start, throwing a lot of load at it. I go to North Virginia, I've got an instance there, actually. Oh, sorry, I stick in Sydney. Just connect to it. It's got a script that I've got here that I've run. So I've got a script here which is, I'm going to run now, which is basically sending lots of curl requests to the back end. You can see the server is loading, all the request is coming through, you're getting your JavaScript. So this is running in the background. And what we have here, when I just go back to our WAF rule, is I'll just leave that running because it takes a little while to get through the 100 requests, is that you can see here we're getting the traffic come through. Sorry, it's a bit small. You can see the traffic being monitored. At the moment, these are all being allowed. At a certain point, it's going to start blocking them. We'll just go back to it. And you can see now this user is getting a 403 error because they're sending too many requests from the same IP address. So that's your easy way of getting up and running with blocking some of those scraping tools that may be pulling down lots of data from your website and overloading it. All right, so that's the first rule. What you may notice when you're in your WAF console is that you have your set of sampled requests is that, for example, fine, you've limited it, but you notice that someone has, a small botnet running out of a particular country. They've compromised set of devices in a given country, and you're getting a lot of requests from one specific country. So in order to manage that, what I'm going to do now is demonstrate how you can block all of the requests from a given country. So I'm going to add another rule, add my own rule, and this time I'm going to block everything from the US. So block US, it's a regular rule this time, sorry, and I'm going to say inspect. So inspect originates from a country in, and I'm just going to say US, United States. The action will be to block, and I'm going to hit add rule, and I'll hit save. So you can see here, hopefully, all going well. The website still works for me sitting here in Australia, in New Zealand. However, if I go to a server I've got in North Virginia, I'm just going to connect to it, connect, oh, wrong one. And I curl, I can't access it, I'm getting 403. So this is a very effective way if you're noticing that you're getting a lot of requests from a specific country that you don't want, to block it, it will never reach your application. Cool.
Question.
Yep.
Is that using it's still using IP blocking but on a geo?
Correct.
Geo IP sort of thing?
Yes.
That's not always dead accurate.
Correct. There's some percentage accuracy, and I believe it's at least 2 nines.
Okay, so it's still accurate.
Yeah, and it is updated regularly. So yeah, it's not perfect, but it tends to be around those sort of, I guess, more transient countries. You could say that, the network controls perhaps aren't as rigorous as other countries. But it's not perfect, but if you're noticing it a lot from one particular country, then it's probably better to do that and protect your legitimate users than, the old person that might be getting through still.
Okay.
Now, one more rule that I want to add. So I added my own rules. What I'm now going to show you is what's called AWS managed rules. So I'm adding a managed rule, which is basically an out-of-the-box rule by either AWS or, as you can see there, a number of our other partners that provide sort of generic protections for your application. And the one that I'm interested in for this evening is Amazon IP reputation list and anonymous IP list. So Amazon IP reputation list is basically our own internal threat intelligence, which has found these are the bots that we've identified, or they're sending DDoS, or they're just doing other bad things. And anonymous IP list is, VPNs, Tor exit nodes, proxies, things that tend to have bad traffic come from them because people are trying to hide their identity, of course. So what I'm going to do is add both of them. And so this just offers a really effective way to block things that we know are just bad. It's a bad host, it's a bad computer, we don't want anything to do with it. I'm going to hit add. Now, I'm going to do something with this rule priority that previously I've just jumped through and hit save. So you can see here we've got rule priorities. So rate limiters first, then block US, and then these managed rules. These are evaluated in order, so if you get blocked here, subsequent rules aren't applied. Now what I'm going to do is I'm going to move both of these up to the top. And the reason is that I want these evaluated first. If it's coming from a Tor proxy, I never want that traffic. I don't want anything to do with Tor. So block it as quickly as we can and move on. And that will become important later on because some of the more complicated rules have a higher cost associated with them. You want to stop them at the front door as early as you can. We'll hit save. And there we are. So basically, what this is doing, these 4 rules in combination, are really getting you to control who are the hosts that can send traffic to you, or lots of traffic. And so this in combination is actually a very effective way to get up and protect yourself against certain classes of denial of service attacks. And as you can see, it's pretty straightforward to get set up and running. Now, in theory, assuming the space's IP address is not going through a Tor proxy or something like that, I should still have access. Good. So clearly the space's IP address is still good. So that's that. All right. So those are...
Hey David,
yeah, sure.
What about the customer response? Like you can
block with a specific HTML for that, or?
Yeah, you can override the response with a specific value if you want. I won't go into that now, but we can talk about that after if you'd like. Yeah, because the response that you get from CloudFront is pretty basic, right? It's not a great experience for your customers.
So you can override this response, okay.
Yeah. All right. Now, unfortunately, I don't have like a Tor exit node that I can demonstrate this with. You'll just have to believe me that they are blocked. All right. So that's all well and good. But how do we start managing bots? So I'm going to add another managed rule. AWS managed rule groups. And you can see here there's one called bot control. So this is one that's specifically built to help you manage bots on your platform. So I'm going to add this to the web ACL, I'm going to hit edit. And you can see there's two levels, common and targeted. I'm going to talk about both, but I'm going to start with common. And common is there for those things that I called simple bots previously. They tend to identify themselves nicely, and you want to also understand how they're coming through to your website and what you can do to mitigate them. So we'll just scroll through and you can see a number of them are described here as,
Sorry about that.
someone got paged. Category advertising, HTTP libraries, monitoring, security tools, automated browsers. And you can see here all of them are set to block that traffic. And so what I'm going to do now is just demonstrate how that works. So I'm going to hit save. I'm going to add that rule. You can see here it's actually at the bottom, which is what we want. As I said, this bot control rule set has a slightly higher cost than the rest. So you obviously, if it's coming from a bad reputation IP address, then why spend money on it? Let's block it at the front. So that's one way to manage the cost of it. Then I'm going to hit save. And there we go. So that's it. Now, what does that look like? Just zoom in. So here I am with curl on my terminal, and then I'm getting a 403, so I'm being blocked. So it's doing what it said on the box, it's blocking curl. If I go to Juice Shop, in theory, I should be able to load the website, so it's not affecting me as a regular user. So that's how you can, manage those common bots. Now, the obvious thing you're asking is, well, I've got monitoring tools that scrape my website to test that it's working and send me alerts when things are broken, or I've got a script with curl that I run that needs to continue running. And so this is where you have to create an exception because you still want to let some of those good bots through. So what I'm going to do now is just demonstrate how you can create an exception for curl, for a well-identified curl cause, while blocking the rest. So let me go back to the WAF console. And what I'm going to do is I'm going to go to my bot control rule set. I'm going to edit it. And you've got category HTTP library here. So you can see currently it's specified to block. What I'm going to do is change that to counts, and I'm also going to change one more, the non-browser user agent. I'm going to change that to count. And what that's doing is that rather than blocking the request, it's going to start counting it. So that's very effective for when you first deploy a rule. Rather than blocking straight away, you want to count it. You want to see how many times it's being invoked, because you want to potentially fine-tune it for your legitimate users. But in this instance, we're just going to set it to count, and you'll see why in a moment. So save rule, I'll hit save, and there we go. And so what I'm going to do is I'll go back to the terminal, the figure, run my curl command again, wait for CloudFront to refresh. So the rules aren't necessarily applied right away, they still need to get distributed to the CloudFront distribution. There we go, so curl's allowed again, but of course, we actually want to block curl for everything but, me on my computer because it's part of my script. So to do that, I'm going to create an exception. And that exception is basically, if it's identified as curl and it doesn't have a secret header that I'm going to specify, then block it. And so what that means is that when I specify curl with my secret header, then I'll be allowed through, otherwise everything else will be blocked. So I'll go and add my own rule group. I'm going to call this allow David. And it's going to be an AND statement. So if it matches two different statements. So the first statement has a label. I mentioned labels before with count. So count generates a label that you can use in subsequent rules. If it is a label which is HTTP library, curl is of course an HTTP library, and it doesn't have a header, a single header. So add request component, single header name, very creative, secret, that exactly matches string secret. So what this is saying is that if it doesn't have the secret header and it's curl, block it. If it does, then cool, you'll be allowed through. So you can see here, the action will be to block. So let me add the rule. The priority needs to be after this bot control rule set because I need to allow David based on the label. Hit save, and we should be good to go. So I'm just going to go back to the terminal, going to run curl. You can see I'm getting blocked again. That's what I want because I don't have that header. Then I run /h secret. Boom, I'm allowed. So obviously you want something a bit more secure than secret, but it just gives you a sense that this is how you can carve out those exceptions. Equally, you can allow monitoring. So we have ways of detecting if it's like pingdom or New Relic or Route 53, because you probably want to allow them. So you can tune it a little bit around your use case and your requirements. Because obviously, as I said at the start, there's good bots and there's bad bots. Some of the good bots you still want to let through.
Can you show the log of this specific curl command?
Yes. So if we just go to overview, it takes a few moments for it to come through.
Yeah.
So you can see here.
So it's not a real time.
The logging isn't.
Yeah, you need to connect it with an instance store.
No, the dashboard here just takes a minute or two to update.
Yeah.
But it is updated, not in real time, but it does take a few minutes to come through. So it will demonstrate in a few minutes here the allowed requests and the ones that were blocked by a specific rule. And so this is how you can fine tune it. You're like, well, why are all these things being blocked by this rule? Is something wrong? It requires a little bit of monitoring. Bots be like, hey, that's cool. You can block curl or Selenium. Where it gets really interesting is, as the sophisticated, the targeted bots, because they're going out of their way to, abuse the sign-up process on your website and register fake accounts, do other bad things with your platform, sign up for free trials and that kind of thing. And so what we're going to do is we're going to edit our rule set for bot control, and we're going to have targeted. So targeted adds a few more things to the equation. You can see here there's a few more rules, including capture and challenge. So one way to detect is it a bot, of course, is to run a capture. The thing with captures is that they're quite disruptive. They don't work very well with single page apps, of course, and they're a bit of a pain for your customers. They're not a great user experience. So we have this other thing called challenge, and as you'll see, we inject a little bit of JavaScript into our website. It runs behind the scenes, generates a token, and then that token, through some magic, validates that it's a human at the browser and not, a bot. And so that's a really powerful way to detect, is this a human, without having to do an inconvenient capture. So I'll hit save. I I'll save it again because the priority is good. All right, so that's done. What I'm going to now talk about is the JavaScript. So on the left here, I've got application integration. There's the WebACL, the bot meetup WebACL we've been working with. There's a JavaScript SDK. And as you can see here, there's a small snippet of JavaScript, and we're going to add that to our website. So I'll do that now. So copy. I will go to the host. I have to pull this up. Remember the file path off the top of my head. So this is the index.html of Juice Shop. So very simple, very standard as you would expect. I will just go to the WAF. I'll grab that JavaScript, copy it in here, and done. So that's all you need to do. Now I will not, you will ask, well, what happens if I've got dev test prod, I've got different environments, is that you can actually integrate this into your CI pipeline with a API. So call the API, get the JavaScript snippet that you need or the URL, and inject it into your index.html, your front end. So it's not as if you're going to have to manually edit your production environment for this. And what's happening behind the scenes here? So what I'm going to do is I'm going to go back to our website. I'm going to go to Developer Tools. Sorry, it is quite small. How do I make that bigger? And I'm going to do a hard refresh. You can see there's stuff happening in the background. It's loading the website, and we're going to go through what's happening here in a moment. How do I make that bigger? So what we've done when we've loaded the page is that we've now pulled down this challenge.js, and that's what's running behind the scenes. It's running a script, it's working some magic, and it's saying, hey, it's David at this computer, it's not a bot. If it's unsure, then it can also generate a captcha, so it can fail back to a captcha if necessary, but for many users, they're never going to have to fill in a captcha, which is really great from a user experience perspective. And what that's doing is, as I said, it's running something on behind the scenes in your browser, and what happens in subsequent requests is that it includes an HTTP header, an HTTP cookie. So if we go to request headers, you can see here it's including a request header AWS WAF token. And so that's what keeps going back in subsequent requests to identify this browser session as a legitimate human and not a robot. And it has a period of time for which it's valid, and then it will regenerate the challenge again. Again, if it gets suspicious, it's like, okay, something weird's happening here, is that it will potentially give you a captcha instead, but that's not the default mode of operation. So that's a very easy way of, protecting your website, identifying bots without having to interrupt the user experience. Now, one final thing I want to mention is how can you manage the costs. So targeted bot control is a bit more expensive than the others because there's a lot more sophistication associated with it. So we have this concept of scope down. So one of the things to be aware of is that, you have static content and you have APIs. Your static content, you might not be too worried if there's a bot pulling down all the images from your website. It's like, okay, fine, so what, I don't care. Because there's nothing particularly valuable there. And you don't equally want to pay for bots to be stopped from doing that, because as I said, there's not a lot of value if they do that. Now that's not always true. If you're in the business of images in some way, then you probably will care about that a bit more, but for most applications, you're not fussed. What you care about is your APIs, the people that are signing up to the website, signing up for free trials, buying buying tickets and stopping other people from them, buying GPUs, whatever it is online that people do, and then scalping them off. So what we're going to do is add what's called a scope down rule. I'm going to go back to my rule. I'm going to go to my managed rule set. I'm going to hit edit. And here I've got scope of inspection. So currently it inspects all web requests, so static content and APIs. What I'm going to do is only inspect requests that match the statement, that have a URI path that starts with /API. I'm going to hit save. Save. And so that's it. So basically now this will only apply to API calls. You might want to filter it down even further if there are very specific, business processes, APIs that, someone signing up for account or, for example, buying something, whatever it is in your business, you can just limit it to that and save yourself some money. So that's just, one good practice to consider. All right, so what we've done now basically is very quickly got set up and running, limit bad IP addresses or people trying to rate limit you or overload your website. We've added basic protections against some of the more simple bots, curl, Selenium, people just trying to scrape data from your website from their home computer. But equally we've added protection to stop those targeted bots, those things executing JavaScript, trying to really do bad things to your website without negatively impacting the user experience of your legitimate users. And as you can see, it took us maybe 20, 25, 30 minutes. So getting this up and running is pretty fast. Don't need to make any architectural changes. There is a bit of fine tuning, of course. Security is hard. The environment changes frequently. The nature of what someone's trying to do with your platform will really depend on your business. So it is something you just sort of need to keep an eye on from an operations perspective, but it's not necessarily very hard to get up and running. So that was a rapid fire introduction to, how you can detect bots, how you can manage them, and how you can mitigate that threat to your application. With that, I'd like to open it up to questions.
I have one. I can see on the rules they have a capacity. What that means?
Right. So basically, there's a level of computation required for each rule. IP rules are very easy. It's very easy to check the IP address. Bot control requires a bit more computation. So those all get added up, and there's a limit to how many you can apply in a rule. So the capacity is basically, in combination, how complex can your rules be? There's a bit of, you can push it quite far. Obviously, you can't compute every permutation of computational complexity, because at the end of the day the request has to be processed very quickly. So this is just our way of limiting the complexity of those rules.
Okay, so the higher is the capacity, probably costs a little more?
Up to a certain point there's no difference, but after a certain point you will pay more. Just because it costs more to compute each request, and you need that to be very performant so it doesn't impact user experience.
Very interested in the DDoS attack, especially around the credential lines, right? So, for example, like AWS is integrated with Azure AD, which is control your credential, and then there's again with for example, Snowflake or something. So, if the attack coming from Azure AD, can this attack from like other providers instead of AWS itself?
So you mean credentials, like credential stuffing attacks?
So for example, like it's not solely based on AWS. So Azure AD is built on top of AWS, right? And then like Snowflake is built on, so integrated together with AWS and then Azure AD. So if the attack is coming from Azure, so can this detect the attack from Azure?
So one of the things, I'm just trying to think how to answer this. So what I didn't discuss today was the account stuffing attack. There is a separate rule where if someone has that list of credentials, is that what you mean? Someone has a list of credentials?
For example, like overlapping IPs or like list of different credentials. Yeah.
Yeah, so if someone gets like a list of credentials off the dark web, is that what you mean?
Absolutely.
Yeah. So there is another rule that I didn't discuss today, but basically if someone has a list of credentials that they got off the dark web, this is my username, this is my password, I decide to use it across multiple websites, is that you can add another rule that will look at a specific pattern in the login request, and it will see, is someone enumerating through passwords, or is someone using a set of passwords that we know have already been compromised because they're public, or is it a bot that's trying to evade detection and we want to block it as well. So there's a separate rule set to do that. I didn't cover that today, but it is possible, yes.
Gotcha. And is the developer defining the rule, or AWS also generates some of the rules?
So for that one, we've got account takeover prevention is what it's called. So I'll just show you quickly, is that you can specify the login path and you specify the username and password field, and then it will check your login page when you submit your login page, whether it's using those compromised credentials or it's a bot that's enumerating through it. They do it for credit cards as well. I know from a former life is that they'll get a list of credit cards off the dark web and they'll just try and test them against your website, and you get in trouble with the banks, and it's a bit of quite an inconvenience.
So, is it possible if we can decode that JWT token that you showed earlier, web token?
Do you mean the cookie?
Web token you showed earlier?
So this is a cookie.
Alright, so it's not possible to decode this?
It's what, sorry?
It's not possible to decode
No,
this?
it's a secret source.
Okay, that's good.
Yeah.
This is obviously for web applications and things, but what happens with, say, another service within Amazon, something like that, is used for doing the attacks? Does the WAF work on internal
So-
from the Amazon instances, or is it just basically it's essentially the same as just another IP range and stuff?
Yeah, so the rule set here, sorry, let me just go back. The rules here, these IP lists exclude the Amazon data centers, AWS data centers, so they're not included. So if there's another EC2 instance that someone has spun up to, launch a lot of requests against your website, is that that wouldn't be blocked by this. There's a whole lot of internal checks and balances that may detect it separately to AWS WAF, but it wouldn't be picked up by this. You'd need to work through the standard bot control rule set to pick it up.
Right, which is using the standard Amazon firewall and
Well, I mean, if it was detected, then that host would be, there'd be the abuse notice that would go out and it would be managed like that. There's a separate process for someone using an EC2 instance for doing bad things.
Sorry, just to follow on from that, is the rules that are in there, like the ones that are the paid rules, the managed ones, do they get added to real time? Like, so if, for example, one of your customers has created a rule which is getting triggered, will it also benefit other people in there, and does that actually end up potentially blocking a large Amazon range?
So there is an update process. The IP ones are slightly different, but it comes from our own internal threat intelligence analysis. I'm not aware of a false positive like that happening previously. I know the other rules are updated fairly regularly as well, like the log4j issue that happened a few years ago, there was actually a mitigation put in place, I think, within 24 hours, and it was rolled out as part of one of the other managed rules. So there is a bit of an update process. I haven't heard of false positives like that. I'd be, if someone does encounter that, I'm more than happy to talk about it, because I would find that quite interesting, and I can certainly route that through the right people internally to see how we can manage it.
You see where I'm going, I was sort of thinking if some of those managed rules get updated because the customer's using it and it's getting triggered quite a bit, and it automatically adds those things for that customer, does it get shared between other customers
Yeah.
using the same rule, and then
Yes.
used as a denial of service on the actual WAF itself?
I mean, that's a logical possibility. It's just not one that I've seen before in real life. Because usually what we do is we detect that this is an IP that's being used for a botnet, and so we can share that knowledge across lots of different customers. Because if it's being a botnet for one, then it's quite likely, I should say, that it's going to be used as a botnet against another customer. So it's share that knowledge across multiple customers. But there is the possibility of a false positive. It's just not something I've seen before.
Does the AWS have like a rule, like if a customer starts to do these things, like ban their account or something?
Yeah, there's a whole process around, usually it's not someone themselves who owns the account doing something bad, it's their account has been compromised. Access credentials leaked on GitHub is used to be fairly common, and there is a whole process around that and how that gets managed.
So how easy is to see the requests that were blocked there? Like, can we see the payload? Can we see which is the root that blocked the request? Is it something easy to
Yeah, you can see. This was, for example, me being blocked. This is the IP address here, and the time. You can dig into some of the details in more detail as well, but that's separate. So separately, I haven't got that available at the moment, unfortunately. But it won't give you the whole request payload necessarily, like a post body. But there's additional details you can pull out.
It would be really interesting to know what is it that they are trying to do with the request.
Yeah, I guess at the end of the day, especially with some of the post requests, there's some storage challenges that becomes difficult to manage. Hey.
Is there some sort of alert you can turn on as well to let you know that a particular role is being hit or not?
Yeah, so you can create CloudWatch alarms. This all goes through to CloudWatch as well. So if you find that you're getting a lot of blocked requests for a certain role that you've got like a baseline for, then yes, you just create a CloudWatch alarm and use your standard processes around that. Anything else? Excellent. All right. I'll hand it back to in the back.